Hi boys and girls, I'm going to go over this ENNY-MOD review with you so that you can check your answers. Number 1 said to use your ruler to draw a rectangle that measures 4 1/4 by 3 1/2 inches and find its area. Alright, I'm going to show you what to do using the regular paper that you're using. So we've got to make a 4 1/4 by 3 1/2 inch. So if you look, you can see that each square here in our grid paper is a 1/2 inch. So that means 2 whole squares would equal an inch. So I've got to have, let's see, 1, 2, 3, 4 1/4 total. So I'm going to start at 0. I'm going to do 8 1/4, or actually 8 1/2 boxes. It's going to make 4 1/4 inches. Now I've got to make it by 3 1/2 inches. Sorry, I'm going a little out of your window here. I've got to make 3 1/2. So I've got to make 3 whole and 1/2, which would be 7 boxes, which looks to me is all of the boxes that is given to you. So we're going to draw a line down our 7 boxes. I'm going to do the same thing down the other side. And then we're going to connect our 4 1/2, or excuse me, 4 1/4 on the bottom. So that is the rectangle that we just drew. And now we're going to find its area. We can find its area in many different ways. We could do 4 1/2, or sorry, 4 1/4, keep saying that, times 3 1/2. Okay, so we could do 4 1/4 times 3 1/2. If we did it this way, we do 4 times 4 is 16, plus 1 is 17, so 17/4. Times 2 times 3 is 6, plus 1 is 7, times 7 halves. And then 17 times 7, 7 times 7 is 49. 7 times 1 is 7, plus 4 is 11, so we have 119 over 8. And 119 divided by 8. 8 times 1 is 8. 11 minus 8 is 3. Bring down the 9. I know 8 times 4 is 32. And I get 7 left out of 8. So I have 14 7/8 as my area. Or I could have just done each of these as a half. So this would be a half all the way, and these would be a quarter. Okay, so what we could do is we could say this is 4 1/4. Sorry, I had to turn that around so I could write. And this here is 3 1/2. Okay, so 3 here and 1/2 here. And we can do 3 times 4 is 12. Okay, so this entire area is 12. 3 times 1/4 is 3/4. So this little area here is 3/4. 4 times 1/2 is 4 halves. And 4 halves is equal to 2. And then 1/4 times 1/2 is 1/8. And then all we'd have to do is add up all of those, because they're basically partial products. So we have to add 12 plus 2 is 14. And 14 plus 3/4 plus 1/8 will give us our answer. So I can't add 3/4 and 1/8 without changing to common denominators. So I'd change 3/4 to 6/8. And 14 plus 6/8 plus 1/8 is 14 7/8. So either way I did this problem will get me the correct answer of 14 7/8. Heather has a rectangular yard. She measures it and finds out it is 18 1/2 feet long by 12 1/5 feet wide. She wants to know how many square feet of sod she will need to completely cover her yard. Part A wants us to draw the yard and label the measurements. So we know that it is a rectangular yard, and we know that the length is 18 1/2 feet, and the width is 12 1/5 feet. So that's all we had to do for part A. Now, how much sod will Heather need to cover the yard? We know that the formula for area equals length times width, and if you find the area, you find out all the space that's within a section. So we're finding all of this area. okay, by doing length times width. That'll give us all this area. So we're going to do 18 1/2 times 12 1/5, and that's going to give us the area. We know that we can't multiply mixed numbers without changing them to improper fractions first, or we have to multiply whole number times whole number times fraction, fraction times whole number, and fraction times fraction, and then add them together. We could also use an area model to do this. Okay, I know that most of you prefer to change to improper fractions, so we're going to do 18 times 2. 2 times 8 is 16, 2 times 1 is 2, plus 1 is 3, so I have 36 plus 1, which is 37, so I have 37 halves. 5 times 12 is 60, plus 1 is 61 fifths. Okay, and over here I'll do 37 times 61. 7 times 1 is 7, 1 times 3 is 3, placeholder. 6 times 7 is 42. 6 times 3 is 18, plus 4 is 22. 7, 5, 2, 2. So I have 2,257 over 10. And I know that if I divide 2,257 divided by 10, I know my decimal's right here. If I move it back one place, I'll have 225 7/10 feet squared as my answer. So this can be written as 225 7/10 as a decimal feet squared, or it can be written as a fraction, 225 7/10 feet squared. That is the area of the yard. Now C says if each square foot of sod costs 80 cents, how much will she have to pay to cover her yard? Well, we know that we have 225 7/10 feet, and they cost 80 cents. So I'm going to multiply it by 80 cents. Okay, some of you may be able to get rid of the 0 and the 80, but some of you may not, so I'll just do it either way. We know we have to multiply by 10 to make that a whole number. We have to multiply by 100 to make this a whole number. 0 times 7 is 0. Since all of those are going to be 0, I can go right to the next spot. 8 times 7 is 56. 8 times 5 is 40, plus 5 is 45. 8 times 2 is 16, plus 4 is 20. 8 times 2 is 16, plus 2 is 18. Because we multiplied by 1,000, 10 and 100 over here, we have to divide by 1,000. Divide by 10, divide by 100, divide by 1,000. The cost to sod the entire yard is $180.56. A rectangular container that has a length of 40 centimeters, a width of 15 centimeters, and a height of 20 centimeters is filled with water to a depth of 12 centimeters. When an additional 5.5 liters of water is poured into the container, some water overflows. How many liters of water overflow the container? So, to help me understand this, I'm going to draw the container. And I'm going to read the first part first and just make sure that I'm understanding. So it's got a length of 40 centimeters, a width of 15, and a height of 20. Okay, it's filled to a depth of 12, so it's not quite, a little over halfway, so it's filled to 12. Okay, then it says when an additional 5.5 liters of water is poured into the container, some water overflows. How many liters of water overflow the container? Well, first, let's figure out the volume of the entire container. We know that volume equals length times width times height. So we're going to do 40 times 15 times 20. And 40 times 15 is 600. 600 times 20 is 12,000 cubic centimeters. Okay, that's the entire volume of the entire figure. So this entire thing here. Okay, now let's find the volume of just what the water is that's already in there. Okay, so we're going to do 40 times 15 times 12. And again, 40 times 15 is 600. 600 times 12 is 7,200 centimeters cubed. Okay, so now let's find out how much space is left in the container. Let's find out how much this volume is, the volume that is not filled with water. So let's take our 12,000 and subtract our 7,200. we get 8. We subtract and get 4,800 cubic centimeters. Okay, so there's 4,800 cubic centimeters left. And there's 5 5/10 liters that's poured in. Well, I know 5 5/10 liters, and I know that 1 cubic centimeter is equal to 1 milliliter. Okay, so this 4,800 centimeters is also equal to 4,800 milliliters. Well, let's change that to liters so that we can work with the 5 5/10 liters. So I know that there are 1,000 milliliters in a liter, and I'm going from a small unit to a big unit, which means I have to divide. So if I take 4,800 and I divide by 1,000, because there's 1,000 milliliters in a liter, I get 4 8/10 liters. Okay, so I have 4 8/10, and 5 5/10 was poured in. And if I take away 4 8/10, that's going to tell me how much spilled over, right? So let's do that. 15 minus 8 is 7, and 4 minus 4 is 0. So 7/10 of a liter is what overflowed our container. Jim says that a 4 1/4 inch by a 2 1/3 inch rectangle has a section that is 4 inches by 2 inches and a section that is 1/4 inches by 1/3 inches. That means the total area is the sum of these two smaller areas, or 8 1/12 inches. Why is Jim incorrect? Use an area model to explain your thinking. On these problems, I like to just do the math using the area model so that I can prove that he's wrong. So I'm just going to take the problem that was provided to him, 4 1/4 inches by 2 1/3 inches. And let's see what we get, and then we can compare it to what Jim got. 4 times 2 is 8. 4 times 1/3 is 4/3. 2 times 1/4 is 2/4. And 1/4 times 1/3 is 1/12. We have to add all of our partial products, which is 8 plus 1 1/3 plus 2/4 plus 1/12. So we've got 9 as a whole, and we're going to change all of these to a denominator of 12. 3 times 4 is 12. 1 times 4 is 4. 4 times 3 is 12. 2 times 3 is 6, plus another 1/12. We've got 4 12ths plus 6 plus 12ths plus 1/12, and that equals 11/12. So we have 9 11/12 inches squared, and that's the area of that rectangle. Well, let's see what Jim said. He said that a section that's 4 by 2, okay, he got this section, and he said there was a section that is 1/4 by 1/3, and he got this section. He said he got 8 1/12, and we got 9 11/12. Well, he forgot 2 sections here. We need to remember, Jim, that when you're multiplying a mixed number times a mixed number, you actually have to get 4 partial products and then add them together. So you don't just multiply the whole numbers and just multiply the fractions and then add them, which is what Jim did. We have to multiply whole number times whole number times fraction, whole number times fraction, fraction times fraction. Okay? Miguel and Jackie built towers out of craft sticks. Miguel's tower had a 5-inch square base. Jackie's had a 4-inch square base. If Miguel's tower had a volume of 150 cubic inches and Jackie's had a volume of 112 cubic inches, whose tower was taller? So we know Miguel and Jackie are who we're working with. Miguel's tower had a 5-inch base. What does that mean, 5-inch base? Well, that means the area of the base. So that means, if this was our figure here, the area of the base, which is just this bottom section here, if I were to draw in what was actually under here, just this bottom section is the base, okay? But they also give us the entire volume, which is 150. So what formula for volume do you think we'll be using? Volume equals length times width times height, or volume equals base times height? Yes, we're going to use volume equals base times height. We're going to take the volume of 150 and the square base, or the area of 5, times a number is going to tell us what the height is. So we know we could take 150 and do the inverse operation of multiplication, which is division. I'm going to do 150 divided by 5, and we get 30. So the height of Miguel's is 30 inches. Okay, now Jackie had a 4-inch square base. Okay, so we're going to use the same formula. Volume equals base times height. So the base is 4. We don't know what the height is. And we know that her volume is 112 cubic inches. So we're going to take 112 and divide it by 4, and that's going to tell us what our height is. So I know that 4 times 2 is 8, and I get 3, bring down the 2. I know that 4 times 8 is 32. So I know that her height is equal to 28 inches. Now let's work with some quadrilaterals. It says read the statement, circle true or false, explain your choice using words and or pictures. All shapes are quadrilaterals. Well, let's think about some shapes. We know we have rectangles, we have squares, we have circles, we have triangles, we have rhombuses. Okay, are all of those quadrilaterals? Think about what makes a quadrilateral. Well, quad means 4, so it's got to have 4 sides. Yep, has 4 sides, has 4 sides. No, does not have 4 sides. Does not have 4 sides, has 4 sides. So is it true that all shapes are quadrilaterals? Nope, it is false. All rhombuses are squares. So a rhombus, we know, has what? And a square, we know, has what? We know that a rhombus has 4 equal sides. Does a square have 4 equal sides? Absolutely. We know that squares have 4 right angles. Do rhombuses have 4 right angles? No, not necessarily. So are all rhombuses squares? No. That's because some rhombuses don't have 90-degree angles. So not all rhombuses have 90-degree angles. Rectangles are parallelograms, but not trapezoids. Well, think about what makes a trapezoid. A trapezoid has at least one pair of parallel sides. Okay, does rectangle have at least one pair of parallel sides? Yes, it does. And parallelograms have 2 pairs of parallel sides. Does a rectangle have 2 pairs of parallel sides always? Yes, it does. So the answer is true. I apologize for the picture of the rhombus below because this picture does not have all equal sides or show all equal sides. But the question says the opposite angles in a rhombus have different measurements. So we'll imagine this is a rhombus. The opposite angles, meaning the angles that are opposite of each other, have different measures, it says. Well, no, because this angle has to be the same as this one, and this one has to be the same as this one, and all of them have to equal 360 degrees. So this statement is false. E says because the angles in a square are 90 degrees, it is not a parallelogram. Well, parallelogram doesn't necessarily have to do with angle measurements. Parallelogram has to do with opposite sides are parallel. So this statement is false. The sum of the angle measures of any square is greater than the sum of any angle measures in any trapezoid. Okay, this is false because the sum of all angles of all quadrilaterals always add up to 360 degrees. So whether it's a trapezoid, a parallelogram, a rhombus, a square, a rectangle, all of them will add up to 360 degrees. G says the following figure is a parallelogram. Okay, so we know, what do we know about the angles? So this wants us to look at the angles since it's giving us angle measurements. We know that the angles should all add up to 180. And if it's parallel, the opposite angles are going to be equal. Okay, and the angles that are next to each other should add up to 180. So 120 plus 50 is 170. Ooh, does not add up to 180. And if this one was 50 and this one was 120, that'd also be 170. And 170 plus 170 is 340, not 360. So there's no way that that figure could be a parallelogram. I hope this review has helped you to study for your assessment coming up. Thanks for watching.